Today's lesson is Chapter 4, Lesson 2, Solving Inequalities Using Addition and Subtraction. The essential question for this lesson is, how can you use addition or subtraction to solve an inequality? So basically, how we want to look at solving inequalities is basically the same as how we looked at solving equations, right? In order to solve equations, we learned to use inverse operations, which means we're going to also use inverse operations to solve these inequalities. Basically, what we're trying to do here is we're going to, inverse operations is telling us to undo the operations that we see with the opposite operations. All right, so we're going to be using the opposite operations to solve these inequalities. Okay. What allows us to use inverse operations are a couple of properties that we'll just briefly talk about. We have the addition property of inequality that basically just says that if we add the same number to both sides of the inequality, we're not changing the value of the inequality. It's kind of like what we did with equations. If we add the same number to both sides of the equation, we're keeping both sides happy or equal. All right, it's like two neighbors. What you do to one neighbor, you do to the other neighbor to make sure that they're both happy. All right, so if we're going to add to both sides of the inequality, then both sides of the inequality remain basically the same. They stay the same, or they're both happy. If we subtract from both sides of the inequality, we basically have the same thing, the subtraction property of inequality. As long as we do the subtraction to both sides of the inequality, then both sides are happy and the inequality does not really change. It might look different, but it doesn't really change. Okay, so that's very similar to what we did with the equations. All right, so let's take a look at our first example here, solving an inequality using addition. So we have the problem, solve x minus 5 is less than negative 3, and then graph the solution. So my inequality is x minus 5 is less than negative 3, and I'm just going to undo what's happening here so that I can get x by itself. The goal is to get x by itself, x less than something. All right, and in order to get there, we're going to use inverse operations. We're going to do the opposite of what we see. I have x minus 5, so I'm going to do the opposite and add 5. And what I do to one side, I need to do to the other side. Like equations, we can write a line down through so that we can separate both sides of the inequality and keep both sides straight. All right, so the minus 5 and plus 5, they cancel out to 0. So all I have left on this side is the x that I'm looking for. And on the other side, I have negative 3 plus 5. If you were to punch that into a calculator, negative 3 plus 5 gives us a positive 2. Now we're going to use what we learned back in lesson 1 in chapter 4 with graphing the inequalities. So I have x is less than 2. The 2 is my starting point. So I want to have a 0 somewhere on my number line. Here's a 1, a 2, a 3, and a 4, a negative 1, a negative 2 on this side. I don't need to put all those numbers, but just a couple of them, just so I can see, where they are on the number line. And x is less than 2, so 2 is our starting point, but I have to look at my inequality sign and see if it's going to be open or closed circle. It's just less than 2. It doesn't say equal to 2, so that means I'm going to have an open circle, all right? And all the values of x that make it true have to be less than 2, which means it goes to the left, because that's where all the numbers that are less than 2 are on a number line. All right? And the last thing we have to do is we have to check our solution over here. What does it mean to check a solution? It means to take a number, any number that is in this area where the number line is. All right, any number that we can pull from this number line and plug it into our original inequality. X minus 5 is less than negative 3. So I'm going to take any number to the left of that 2. All right, because those are the numbers that are part of the solution set. So I'm going to take the number 1, that's to the left of 2, and I'm going to plug it in and see if it works. So I'm going to have x, whoops, sorry about that. I'm going to plug in 1 for x, so I'm going to have 1 minus 5. should be less than negative 3. 1 minus 5 on this side is negative 4, is then less than negative 3. And now I have to think about a number line. Is negative 4 less than negative 3? Well, here was 0, and I was moving to the left. I would get to negative 3 first, and then I would get to negative 4. What does it mean for negative 4 to be less than negative 3? That means it has to be to the left of negative 3 on the number line. And a negative 4 is to the left of negative 3 on the number line, so that, in fact, is true. And I put a check mark so that I know that I checked it and it worked. All right, so that's basically it as far as solving inequalities using addition. So we have some on your own problems here to do, where you're going to use addition to solve the inequality. Some with whole numbers, some with decimals, and one with fractions. But the way you do it is the same for all of them. It's just that you're adding whole numbers, you're adding decimals, or you're adding fractions. So go ahead and do those on your own. Use a calculator to help you out with those. That's fine. Pause the video, do those, come back in a few, and check your solutions. Okay, hopefully you've taken care of those problems. So I am going to go ahead and solve them for you so that you can check your answers. So let's take a look at the first one here. Number 1, y minus 6 is greater than negative 7. So in order to undo what I see here, I have a minus 6 with my y. So I'm going to add 6 on this side, which means I have to add 6 on the other side. Put a little line through there. And these negative 6 and positive 6 are going to cancel out. All I have left is y. I keep my greater than sign. And negative 7 plus 6 is equal to negative 1. So y is greater than negative 1. So I'm going to go ahead and put that on my number line. I'm going to graph it. Let's say this is 0, and let's say negative 1 is over here. Positive 1 would be over there. I don't really need any more than that. So y is greater than negative 1. Negative 1 is my starting point. It says greater. It doesn't say equal, so I'm just going to put an open circle at negative 1. And it says y is greater than negative 1, so the arrow must go to the right, where greater is on a number line. Now, if I want to check my solution, I take a number that's to the right of negative 1, and I plug it in to my original inequality. Let me do that up here, or actually I can do this down at the bottom. So I have y minus 6 is greater than negative 7. So let me take 0 and put it in there. 0 minus 6 is greater than negative 7. Well, 0 minus 6 is negative 6. Is negative 6 greater than negative 7? Well, on a number line, negative 6 is to the right of negative 7, so yes, it is greater than negative 7, so that works. All right, the second one, b minus 3.8 is less than or equal to 1.7. So again, I need to get rid of this minus 3.8, so I'm going to add 3.8. And I'm going to do that to both sides of the inequality. The negative 3.8 and positive 3.8 cancel out to 0. All I'm left with on the left side is a b. I still have less than or equal to, and then I have 1.7 plus 3.8. I'm going to add those together. 7 and 8 is 15. I'm going to carry the 1. 1 and 3 is 4 plus the 1 up top is 5. So that'd be a 5.5. Got to bring my decimal point down. So b is less than or equal to 5.5. So on the number line, I'm going to put a 0. I'm going to put a 5.5 somewhere over here to the right, because I know 5.5 is positive, has to be to the right of 0. Now it says that b can be less than or equal to 5.5, so I'm going to put a closed circle there because it's allowed to be equal to it. And then it also says it can be less than 5.5, so that's going to be an arrow that goes to the left. Now, if I want to check and see if that works, I can take any number to the left of 5.5 and plug it in. So I'm going to take 0 again. That seems to be an easy one. b minus 3.8, less than or equal to 1.7. If I plug in 0 for b, I get 0 minus 3.8. It's less than or equal to 1.7. 0 minus 3.8 is negative 3.8. Is less than or equal to 1.7. Should be an equals there. And any negative number is automatically less than a positive number, so that must be true. Okay, number 3, now we got fractions. Negative 1/2 is greater than z minus 1/4. So the z, the variable, is on the right-hand side, so I got to find that and then say, okay, what's happening here? I got minus 1/4. So to undo that, I'm going to add 1/4. And I'm going to add 1/4 to the other side as well. I got to do the same to both sides of the inequality. Negative 1/4, positive 1/4 cancels out to 0, and all I have on this side is a z. All right, I keep my inequality symbol the same as it is, and I have negative 1/2 plus 1/4. If I add those in a calculator, I'm going to get a negative 1/4 for my answer. All right, so I have to go ahead and graph that. Now, remember, when we're graphing, we want to read the inequality starting with the variable and read it towards the number side. So this, to me, when I read it starting with the variable, says z is less than negative 1/4. So somewhere on the number line, I'm going to put my 0. I know that negative 1/4 is less than 0, so it has to be to the left somewhere. So I'll just put it here. Doesn't really matter where it's at. Okay, that's negative 1/4 right there. Now, it says z is less than negative 1/4 if I read it that direction. Less than doesn't say equal to, so it has to be an open circle. And z is less than the negative 1/4, that means it goes to the left. All right? It's much easier to read or to graph when you read it from the variable towards the number. Now, if I want to go ahead and check this, I got to pick some number less than negative 1/4, some number to the left of it. So I'm going to take negative 1. That would be to the left of it, and I'm going to plug that in. I'm going to go up to the top to do this one. I have negative 1/2 is greater than z minus 1/4. Now, negative 1/2 is going to be greater than z. I'm going to put in negative 1 minus 1/4. Negative 1/2 stays the same, but greater than. Negative 1 minus 1/4 is negative 1 1/4. If we do that in our calculator. Negative 1 1/4 is less than negative 1/2. Or another way to say that, negative 1/2 is greater than negative 1 1/4. If I put them on a number line, all right, negative 1 1/4 is here, and negative 1/2 is bigger. It would be over here. So that makes this true. Negative 1/2 is greater than negative 1 1/4, so it does work. Again, if you have any questions on this, make sure you ask in class, and I'm more than happy to go over some more of these problems with you to make sure that you know what you're doing. All right, so that was solving using addition. Now we're going to do some using subtraction. Same thing we're going to be doing. We're just going to look at the problem, and we're going to try to get rid of the numbers that we need to get rid of so that we can get x by itself. Solve 13 is less than or equal to x plus 14, graph the solution, and then we'll check the solution. So I've got 13 is less than or equal to x plus 14. So my variable x is on the right-hand side, and I've got plus 14 that I need to eliminate or get rid of. So I'm going to do the opposite to get rid of it. I'm going to subtract 14 on both sides. All right, what I do to one side, I got to do to the other side. So the positive 14 and negative 14 cancel out to 0. I'm left with x on this side. I still have a inequality symbol to bring down. And on the other side, I have 13 minus 14. 13 minus 14 in my calculator is negative 1. So I have negative 1 is less than or equal to x. But again, to graph it, I would read it the other way. I would start with the x. X is greater than or equal to negative 1. So on my graph, I put a 0. Negative 1 has to be to the left of it. All right, positive 1 would be to the right of it. It says x can be greater than or equal to it, so that means it's going to be a closed circle at the negative 1, and greater than the negative 1, since x can be greater than or equal, would be to the right. Now, to check this solution, I want to take a number to the right of negative 1 and plug it in and see if it works. So I'm going to plug in the 1. I have 13 is less than or equal to x plus 14. I'm going to plug in 1 for x, and I'm going to go ahead and simplify. 13 is less than or equal to 15. And 13 is less than 15, so that works. All right, so you've got some on your own problems to do here. I'm going to do them just the way that we did the one above. Again, number 4, you're dealing with whole numbers. Number 5, you're dealing with decimals. And number 6, you're dealing with fractions. But it's all the same thing. It's just plugging different kinds of numbers into your calculator at this point. All right, so you go ahead, pause the video, work those out, and then come back in a couple of minutes when you're done, start the video, and you can check your solutions. Okay, so hopefully you've got those taken care of. And let's go ahead and start with number 4. We have w plus 7 is less than or equal to 4. So I'm going to subtract 7 from both sides because I want to get w by itself. So I'm going to subtract the 7 from both sides. And when I do that, plus 7 and minus 7, they cancel out to 0. All I got left is w here. I keep my inequality symbol. And on the other side, I have 4 minus 7. 4 minus 7 is negative 3. I'm going to go ahead and graph that. W is less than or equal to negative 3. Negative 3 is my starting point. I've got to have a 0. Let's say negative 3 is over here. On the other side, there's a positive 3 over there. W is less than or equal to negative 3. So equal says it has to be a closed circle, and the less than negative 3 says it has to go to the left. Again, I read it from the variable towards the number. W is less than or equal to negative 3. If I want to check this, I got to take a number that's to the left of negative 3, somewhere where the arrow is. So I'm going to use negative 5, and I'm going to check and see if that works. W plus 7, less than or equal to 4. I'm going to take negative 5 for W and add it to 7. And then go ahead and simplify. Negative 5 plus 7 is a positive 2. Is 2 less than or equal to 4? Yes, it is less than 4, so that works. Check mark. Number 5, 12.5 is greater than or equal to D plus 10. So I see my variables on the right-hand side. So I need to get rid of that plus 10. So I'm going to subtract 10, do the opposite on both sides. All right, so I'm going to do that. 12.5 minus 10 on this side is 2.5. Keep my inequality symbol. On the other side, the positive 10 and negative 10 cancel out, and I just have D. All right, now this is D is 2.5 is greater than or equal to D, but for graphing purposes, I want to read it the other way. D is less than or equal to 2.5. 2.5 is my starting point, so I'm going to mark as 0, and I'm going to put a 2.5 over here. On the other side, I could have a negative 2.5 if I want. I don't really need it. As long as you have the 0 and the starting point, I think that's good enough. So it says D is less than or equal to 2.5. So it can be equal to 2.5, so we got to put a closed circle in 2.5. And it says D is less than or equal. Less than tells me it goes to the left. Remember, I read it from the variable towards the number to help me graph it. Now, let's check and see if I went the right direction with my arrow by taking a number to the left of 2.5 and plugging it in. So I'm going to start with 12.5 is greater than or equal to D plus 10. I'm going to use 0. That's to the left of 2.5, and that's an easy number to use. I'll plug that in. 12.5 is greater than or equal to 0 plus 10, and I'm going to simplify. 12.5 is greater than or equal to 10. 12.5 is greater than 10, so that works. And then the last one, x plus 3/4 is greater than 1.5. So I see the variables on the left side. I've got this plus 3/4 that I need to get rid of, so I'm going to subtract 3/4 from both sides of my inequality. On the left side, the positive 3/4 and the negative 3/4 cancels out to 0. I'm left with just x. Keep my inequality symbol, greater than. 1 1/2 minus 3/4 in your calculators will give you 3/4. So I have x is greater than 3/4. Again, reading it from the variable towards the number to make it easiest to graph. So I have to have a 0. And somewhere to the right of 0, I have to have 3/4 because it's positive. Anything positive is to the right of 0. So I'll put 3/4 right there. I don't really need any other numbers on here. So it says x is greater than 3/4. It doesn't say it's equal, so I'm just going to put an open circle at the 3/4. And it says x is greater than that 3/4, so that means everything to the right is what makes it true. All right, that's our solution set to the right. Now let's check this to make sure that it works. So I'll take any number to the right of 3/4. So I'm going to take the number 4. Let's plug that in. All right, so I'm going to get 4. You know what? Let's rewrite the inequality first. Sorry, I didn't mean to get rid of my 0 there. So let's have x plus 3/4 greater than 1.5. And I'm going to take 4 and put it in, because 4 is to the right of 3/4. 4 plus 3/4 is greater than 1 1/2. Add 4 plus 3/4, I get 4 3/4 is greater than 1 1/2. 4 3/4 is greater than 1 1/2. So we check that off and we're good. All right, so that's the lesson. We have some exercises here, and I've highlighted some of the questions. Those are the ones that we want to see you do to show that you understand the lesson. And, you know, if you can't do these problems, then you need to be asking questions. So you're going to do number 3, number 7, number 11, number 16, and number 20, parts A and B. Do those, make sure you bring those in and turn them into your teacher. And again, if you have any questions, be sure to ask when you come back to school.